Okay, so you want to own a 3D printing business. The pitch writes itself. You buy a machine, you load a file, you press print, and hours later you pull a physical object out of thin air. No employees cutting material by hand, no tooling setup that costs $50,000 before you make part one, no minimum order quantities that price out every small buyer. Just a machine, a file, and a customer who needs something made. That is the version of the story that shows up in the business opportunity videos, the ones with the revenue screenshots and the testimonials from people who claim to have quit their jobs. Here is what those videos leave out. The machine is only the beginning of a cost structure that most new owners do not fully understand until they are already inside it. The margins on the thing people assume is most profitable are frequently worse than the margins on the thing nobody talks about. And the operators who actually build sustainable businesses in this industry have usually failed, pivoted, and rebuilt at least once before they figured out what they were actually selling. By the end of this, you will understand what a 3D printing business actually costs to run, where the money comes from, and where it disappears to. What the operators who make it work are doing differently from the ones who wash out in year two, and why the machine on the desk is almost never the most important variable. Before anything else, you need to understand that 3D printing is not one business. It is a category that contains at least 5 or 6 completely different businesses, each with different customers, different cost structures, different margins, and different failure modes. People who lump them together under the phrase 3D printing business are making the same mistake as someone who says they want to open a food business without specifying whether they mean a hot dog cart or a full-service restaurant. The economics are not comparable. The most common version is desktop filament printing, technically called FDM, which stands for Fused Deposition Modeling. This is the technology most people picture. A spool of plastic filament feeds into a heated nozzle, which deposits material layer by layer until the object is complete. Most of the people selling phone cases, miniatures, replacement parts, and custom decorative objects on Etsy or through their own websites are using FDM printers. The entry cost is low. The competition is enormous. The margins are compressed. Then there's resin printing, technically called MSLA or SLA depending on the exact technology. Instead of melting plastic, a UV light source cures liquid resin layer by layer. The results are considerably more detailed than FDM, with surface finishes that can look nearly injection molded. Dental labs, jewelers, model makers, and tabletop game accessory producers are the core customers. The machines are more expensive to operate because the resin itself costs more than filament. The post-processing steps require additional equipment and chemicals, and the waste disposal involves materials that are not simply thrown in a bin. But the detail quality commands higher prices, and the customer base overlaps less with the mass of FDM operators competing on Etsy. Above both of those sits industrial grade printing, which is a different universe entirely. Selective laser sintering, direct metal laser sintering, multi-jet fusion, carbon DLS. These are the technologies used by aerospace manufacturers, medical device companies, and industrial parts producers. The machines cost anywhere from $200,000 to well over $1 million. The materials, whether engineering-grade nylon, titanium powder, or carbon fiber-filled composites, cost hundreds of dollars per kilogram. The software to run them requires trained operators. The tolerance requirements are tight enough that quality control is a formal process, not a judgment call. This is not a garage business. It is a capital-intensive manufacturing operation competing for contracts with established machine shops and injection molding facilities. And then there's scanning and design, the services wrapped around printing that many operators underestimate until they realize how much of the bill they can charge for things that do not require any machine time at all. Reverse engineering a part, converting a physical object into a printable file, optimizing a customer's design for additive manufacturing, managing the full workflow from concept to finished part. These services carry margins that printing alone rarely matches. Understanding which of these you are actually building determines almost everything about whether the math works. The equipment cost is the number most people start with, and it is also one of the least predictive numbers in the whole business. A Bamboo Lab P1S, which is one of the faster and more reliable prosumer FDM printers on the market as of 2025, costs around $700. A fleet of 10 of them is $7,000. That sounds like a reasonable entry point into manufacturing. The problem is what surrounds the machines. A printer that runs 24 hours a day needs filament. Standard PLA filament from a reputable brand costs between $15 and $30 per kilogram. PETG, which is more durable and better suited to functional parts, costs roughly the same. Specialty materials, carbon fiber-filled nylon, flexible TPU, high-temperature PEEK cost significantly more, sometimes $200 per kilogram or above. A single printer consuming a kilogram of filament per day at $20 per kilogram is a $7,000 annual material cost per machine. 10 machines is $70,000 a year in filament before you have made a single dollar. Then there's electricity. A desktop FDM printer draws somewhere between 50 and 200 watts depending on the bed size and the enclosure temperature. At the national average electricity rate in the United States of roughly 13 cents per kilowatt hour, a printer running continuously at 100 watts costs about $11 per month in electricity. 10 printers is $110 per month, roughly $1,300 per year. That sounds modest until you start adding the humidity control, air filtration for particulate matter from the printing process, the lighting, the computers running the slicing software, and the heating or cooling required to keep the print environment within the thermal range where the machines perform reliably. A small professional print shop in a northern climate can spend several $1,000s per month on utilities once everything is running. There is also the cost nobody in the promotional videos ever discusses in detail, which is failed prints. FDM printing fails. A print that detaches from the build plate halfway through a 6-hour job wastes filament, wastes electricity, wastes machine time, and potentially wastes the slot that should have been filled with a paying customer's order. Experienced operators running tuned machines on familiar materials report failure rates in the 5 to 15% range. New operators on new machines running unfamiliar materials see failure rates that can exceed 30% in the early months. If you are pricing jobs without accounting for a realistic failure rate, you are pricing jobs at a loss and not understanding why. Add to this the cost of post-processing. FDM prints almost always require at minimum the removal of support structures, which are temporary plastic scaffolding the printer adds to support overhanging geometry. Depending on the design, support removal can take anywhere from 2 minutes to 45 minutes per part. If you are paying someone to do that work, or if you are doing it yourself and charging nothing for that time, it is a cost that affects every job you run. Parts that need sanding, priming, painting, or assembly multiply that labor cost several times over. And then there is the equipment lifecycle cost. An FDM printer is not a capital asset that retains its value over 15 years like a commercial injection molding press. A nozzle wears out, the build plate develops surface defects, the belts stretch, the firmware needs updates that sometimes change behavior. Within 2 to 3 years of heavy use, a desktop printer is typically a partial rebuild or a replacement. The maintenance schedule for a professional shop running machines continuously is not something you can ignore or defer the way you might with a piece of office equipment. It's a recurring cost built into the economics of every job you run. Here's the core equation that determines whether a 3D printing business survives. On one side, you have revenue per machine hour. On the other side, you have cost per machine hour. The difference has to be wide enough to pay for the labor, the overhead, the failed prints, the equipment depreciation, and whatever profit margin makes the whole enterprise worth running. Most consumer-facing FDM print services in the United States charge somewhere between $2 and $8 per hour of print time for standard materials, plus a per-gram material charge. Some operators price by the gram only, some by a combination, some by the piece on proprietary items they have developed themselves. The pricing model matters because it determines how well you capture the true cost of any given job. A job that takes 12 hours of machine time but uses very little material, like a large hollow geometric object, will be underpriced by a pure material cost model. A job that uses a lot of expensive material but prints fast will be underpriced by a pure hourly model. Most experienced operators use a combination that reflects both machine time and material consumption, with additional charges for jobs that require extensive post-processing or setup. At $3 per machine hour plus a 20-cent per gram material markup, a print that takes 8 hours and uses 100 grams of filament generates $3 in filament margin plus $24 in machine time, a total of $27 for that job. The actual cost to run that job is somewhere between $7 and $12 in combined electricity, material cost, machine depreciation, and failure rate accounting. On the surface, that looks like $15 to $20 of gross profit per job. The problem is what happens at scale. To generate meaningful revenue from desktop FDM printing, you need volume. A single printer running one 8-hour job per day, 7 days a week at $27 per job generates roughly $9,800 per year in gross revenue. Subtract material costs, electricity, depreciation, and the reasonable failure rate allowance, and the operating contribution from that machine is somewhere between $4,000 and $6,000 per year. That is a contribution of a single machine toward covering rent, your own labor, marketing, software subscriptions, packaging, shipping, and every other overhead cost of running a business. You need several machines running near capacity before the overhead math starts to work in your favor. And running machines near capacity requires a consistent flow of orders that most new operators dramatically underestimate how hard it is to build. This is the first place new owners get into trouble. They calculate what a machine can produce if it is running all the time, and they treat that number as a revenue forecast. The machine is not the constraint. The orders are the constraint. A printer sitting idle produces nothing, costs the same depreciation, and takes up the same floor space as a printer running at full capacity. The economics of manufacturing, including 3D printing, turn on utilization. Low utilization is expensive in a way that the per-job math does not immediately reveal. The operators who understand this early make a decision that shapes everything that follows. They decide, explicitly, who their customer is and what problem they are solving for that customer. That decision is more important than the brand of printer they buy, the material they stock, or the slicing software they prefer. The consumer market is the most visible and the most crowded. Anyone can put a listing on Etsy, a product page on a website, or an ad on social media offering to print custom objects. The customers who find you through those channels are primarily price sensitive. They're comparing your quote to the quote from 6 other operators who run the same machines and the same materials. When price is the primary decision factor, margins compress to the point where the business is really just a part-time hobby with overhead. The operators who try to win in the consumer market on price almost uniformly fail to build something sustainable. The operators who win in the consumer market find specific niches where their output is genuinely differentiated. Miniature painters who need highly detailed resin prints of specific characters. Cosplay builders who need accurate replica props in specific scales. Replacement parts for vintage electronics, vehicles, or appliances where no commercial source exists. These niches have customers who care primarily about quality and accuracy, not primarily about price. The niche operator who becomes the known source for a specific type of output in a specific community builds something that a general-purpose print shop cannot easily replicate. The business market is harder to reach but structurally more favorable. A company that needs functional prototype parts during a product development cycle, a manufacturer that needs short-run production of a component that is not yet justified for injection molding, an architecture firm that needs physical scale models of building designs, a medical device company that needs patient-specific surgical guides printed in biocompatible material. These customers have budgets that are determined by the value of what they're buying, not by a comparison to other print shops. A prototype part that saves 3 weeks in a product development cycle has a value to the buyer that is completely disconnected from the cost of the filament used to make it. The operator who can reliably deliver that part on time, at the required tolerance, in the right material, can price it accordingly. The structural difference between consumer and business customers is not just the price per job, it is the repeatability. A business customer who finds a reliable supplier does not spend time shopping for alternatives every time they need a part. They come back.
They increase their order volume as they develop trust. They refer other people in their industry. A strong B2B customer relationship is worth many multiples of the revenue from any single transaction, and it is the foundation of a print shop that can plan its capacity rather than scrambling for orders one at a time. The dental industry deserves specific attention because it represents one of the clearest examples of how 3D printing has created a genuinely new business category rather than just replacing an old one. Dental labs have been using 3D printing for crowns, surgical guides, orthodontic models, and denture bases for long enough that the technology is no longer experimental. It is the standard. A dental lab that is not printing is a dental lab that is losing business to the ones that are. Resin printers approved for dental use from companies like Formlabs, SprintRay, and EnvisionTech cost between $5,000 and $50,000, depending on the resolution and the build volume. The materials are medical grade, biocompatible, and regulated, and they cost 2 to 8 times what a general purpose resin costs per kilogram. But the output value is correspondingly higher. A set of clear aligner models that takes 40 minutes to print can be billed at $70 to $150. A dental surgical guide that takes an hour to print and requires the lab to process a CBCT scan beforehand can be billed at several $100s. The materials are expensive and the regulatory compliance adds overhead, but the margin per print hour is dramatically higher than anything you will find in the consumer market. The manufacturing services market, which is really what the business-facing side of the industry is, has consolidated around a set of players who are difficult for small operators to compete with on price, but possible to compete with on speed, communication, and specialization. Protolabs, Xometry, CraftCloud, and similar platforms have built networks of vetted manufacturing partners and automated quoting systems that give customers instant prices for parts they need made. For a small print shop, competing directly with those platforms on commodity jobs is a losing proposition. The platform has more capacity, more materials, more certifications, and more marketing than any single operator can match. The small operator who thrives in the face of that competition is not trying to win on price for generic parts. They're winning on the things the platform cannot deliver. Turnaround in 24 hours when the platform quotes 5 days. Direct conversation with a human engineer who can advise on design for printing optimizations that reduce cost or improve the part. Willingness to manage a complex multi-step project from CAD file to finished assembly. Flexibility on materials that the platform does not stock. These are not marginal advantages. These are decisive for the right customer. The mathematics of a print farm, meaning an operation running many machines simultaneously to generate volume, look compelling on paper and punishing in practice. A farm of 50 machines, each running 8 hours of paid jobs per day at an average of $25 per job, generates $37,500 in gross revenue per month. That sounds substantial. Then you subtract.
Filament and resin at 15 to 20% of revenue is $5,600 to $7,500 per month. Electricity for 50 printers plus environmental controls, $3,000 to $5,000 per month, depending on location. Labor to load printers, remove finished parts, handle failures, manage post-processing, and deal with customer communication. At minimum, 2 full-time employees, which at competitive wages in most American cities cost $10,000 to $15,000 per month, including payroll taxes and basic benefits. Rent for a space large enough to house 50 printers, plus storage, post-processing stations, and a functional workflow. Depending on the market, that is $2,000 to $6,000 per month. Machine depreciation and maintenance budgeted at a realistic 3 to 5 year replacement cycle, another $3,000 to $5,000 per month. Add those up at the midpoints and you get roughly $28,000 in monthly operating costs against $37,500 in gross revenue. That leaves about $9,500 per month, or $114,000 per year as operating profit before taxes, before debt service on the equipment financing, and before any owner compensation that is not already in the labor line. For a business requiring several $100,000 in equipment investment and years of operational development, $114,000 in annual operating profit represents a return that serious investors would not find compelling.
The operators who make the math work materially better than that have usually done one of several things. They have developed proprietary products with margins that are not determined by hourly machine rates. They have built long-term contracts with industrial customers that smooth out their utilization and reduce the cost of customer acquisition. They have added high-margin services like design, scanning, and engineering consulting that do not require machine time at all. The proprietary product path is the one that gets the most attention online, and it is both the most appealing and the most difficult to execute well. The concept is simple. Instead of printing other people's files for other people's products, you design and sell your own products. You control the file. You control the price. When someone wants the item, they buy it from you, not from a marketplace where 17 other sellers are undercutting your price by 12%. The operators who have built genuinely successful product businesses through 3D printing share a few common characteristics. They started with a specific audience whose needs they understood extremely well, usually because they were a member of that audience themselves. They iterated the design based on direct feedback from real customers before investing heavily in marketing. They built a brand around the product rather than leading with the technology used to make it. And they treated the printing as a production method, not the product itself. The failure mode in the proprietary product path is treating product design as a one-time effort rather than a continuous one. A product that sells well today will face competition from other operators who copy the design, from overseas manufacturers who can make injection-molded versions at lower cost, or simply from customer fatigue when the novelty wears off. The operators who sustain product businesses do so by continuously developing new designs, building customer relationships that generate repeat purchases, and moving into product categories where the design complexity or the customization requirement makes simple copying difficult. The design and engineering services layer of the business is where a different kind of operator entirely tends to build value. These are people who come to 3D printing not as hobbyists who learn to monetize their machines, but as mechanical engineers, industrial designers, or manufacturing specialists who added additive manufacturing to an existing set of professional skills. Their clients are not consumers looking for custom phone cases. They are companies that need someone who can take a vague product concept, develop it into a manufacturable design, build and test prototypes, refine based on testing results, and produce a finished good specification ready for volume production. The 3D printing in that workflow is one tool among several, and the client is paying for the engineering judgment, not the machine time. Hourly rates for that kind of work start around $75 per hour for junior-level design assistants and can exceed $200 per hour for experienced engineers with relevant industry specialization. The machines running in the background of that business are essentially free samples of the thinking that generated the client relationship. The businesses that fail in 3D printing almost always fail for one of a small number of reasons that in retrospect are visible from the beginning. They underestimate the cost of idle capacity. They price jobs based on material cost only and fail to account for machine time, labor, failures, and overhead. They try to compete on price in markets where price competition eliminates the margin before the business can build scale. They overestimate the speed at which they can build a reliable customer base. They underinvest in the workflow systems that allow them to actually manage 10 or 20 machines simultaneously without spending all of their time firefighting print failures and customer communications. The businesses that succeed usually started by solving a specific problem for a specific customer, charged enough for that solution to build a sustainable operation, and expanded their customer base through referrals and reputation rather than by trying to be the cheapest option in a general search result. The physical technology gets better every year. Printers are faster, more reliable, and cheaper than they were 5 years ago. Materials are more capable. The range of applications is wider. None of that changes the fundamental economics of how a business works. A faster printer running at low utilization is not a profitable business. A slower printer with a full order book and strong margins on every job can be. There is a specific type of operator in this industry that almost always gets overlooked in the promotional narrative around 3D printing as a business opportunity. And understanding what they do differently is the clearest way to see what the business actually requires. These are the people who came from a traditional manufacturing background, spent time in a machine shop or a plastics facility or a medical device company, understood how parts get made and what manufacturers need, and then added 3D printing as a capability on top of that existing foundation. They never had to figure out who their customer was because they already knew who needed what they could do. They never had to guess at pricing because they understood what a part was worth to the buyer, not just what it cost to produce. And they never had to convince anyone that additive manufacturing was worth paying for because they were offering it to customers who had already been paying for manufacturing services and understood the value of better lead times and more design freedom. The new entrants without that background can absolutely build a sustainable business in 3D printing, but they need to understand that the machine on the desk is a capability, not a business model. The business model requires knowing whose problem you are solving, why your solution is better than the alternatives available to that specific customer, and how to price it and deliver it in a way that generates enough margin to cover the full cost of running the operation, including the costs that do not appear in any YouTube monetization video. The most honest way to describe the economics of a 3D printing business in 2025 is this. At the low end, desktop FDM printing for general consumers is a difficult way to generate meaningful income and an easy way to generate a large collection of printers and a very thin margin on every job. At the mid-market, professional print services targeting businesses with specific technical needs can generate solid margins if the operator has the skills and the customer relationships to command prices that reflect the value of the output rather than the cost of the plastic. At the high end, industrial additive manufacturing for aerospace, medical, defense, and advanced manufacturing customers is a capital-intensive, highly technical business where the barriers to entry are real and the rewards for overcoming them are substantial. The operators who succeed at any of those levels share a characteristic that has nothing to do with which printer brand they chose or which material they stock. The operators built a business around the customer that needed what they could specifically provide, and they charged enough for it to make the whole enterprise work. The machines are just the tools. The business is everything around them.